Well, welcome. I'll go ahead and get started. I'm Janet Reyes, the Geospatial Information Librarian at UCR, and happy to spend the next hour or less talking with you about some of the skills that you might want to try out with ArcGIS Pro, especially if you're working with vector data. This is being recorded, and a copy or a recording will be available on the library's YouTube channel in about 2 or 3 weeks once we get the captions all squared away. So look for it there, and I'll paste a link to where you might find that in the chat a little bit later on in the workshop today. I'll also be sending all attendees and all people who signed up for the workshop a copy of the slides. So that means that anything you see today, you'll have access to the links, all the information. So no worries about taking screenshots or anything like that. You'll have all this information later on. I usually have a assistant when I'm giving workshops. I don't have one today, so I might be a little bit slow in recognizing if there's something in the chat, say, or something like that. I think we'll have a small enough group, so if it seems like I'm plowing past whatever people are trying to tell me, and it's okay to unmute yourself and just let me know. Yeah, we'll just try to do it that way, but hopefully all will go well. I think that is all I needed to do in terms of housekeeping. So let me continue on. We'll start with the UCR Land Acknowledgement. We would like to respectfully acknowledge our responsibility to the original and current caretakers of this land, water, and air, the Cahuilla, Tongva, Luiseño, and Serrano peoples, and all of their ancestors and descendants, past, present, and future. Today, this meeting place is home to many Indigenous peoples from all over the world, including UCR faculty, students, and staff, and we're grateful to have the opportunity to live and work on these homelands. And you'll see at the bottom of the slide, there's a link to a map of native lands. It's really pretty interesting to explore sometime if you have the chance and are interested to do so. So here's an overview of our workshop. We'll go over what you need to know basically before you start digging into Pro. Maybe if you're a little rusty using it or just starting to learn about it, I'll just go over some of the basics. And then we'll get into the heart of the workshop. So today we're going to look at how you perform joins, either with tabular data or spatial join. And then we will look at how you make a Choropleth map. That term always sounds so technical, but really what it means is it's a map that uses graduated colors to represent values of different features on the map. And I'm sure you've all seen one, but once we get talking about it, you'll recognize what this is. Lastly, we'll round it out by looking at how you might generate centroids, which are like for a polygon map, you create a point that represents each of the polygons. And then finally, making a heat map. That is a very popular visualization these days in mapping, showing you where clusters of events are happening, or maybe the intensity of the events are represented on the map. So that's what we're going to do today. And by the way, I gave a very similar, like a parallel workshop with these same topics in the fall using QGIS, which is open source software. So if you are interested in comparing and contrasting how you do it in ArcGIS Pro versus QGIS, you can find the recording for that workshop on the library's YouTube channel. Okay, so let's talk about before you start. Well, at UCR, a good way to use ArcGIS Pro, and one I've grown to like, and that's what we'll be looking at today, is using a Porto, which is a virtual machine. So it doesn't matter how unpowerful your laptop is or how old it is or whatever. If you use a virtual machine, you can access all the functionality of Pro and not have to worry about processing time or anything like that so much. So steps to access a Porto are on your screen, ucrporto.com. You log in with your NetID and password, and then you'll see a screen that gives you a few choices. And the one that you want to pick to use ArcGIS products is the GPU apps box. So you click that launch there and off you go. Now, if you do want to use ArcGIS Pro on your desktop instead of in the cloud, there is a way to do that. You probably want to do that by establishing an ArcGIS Online account. And once you do that, there's a way to get to an installer for ArcGIS Pro within ArcGIS Online. You can navigate to that. And also having an ArcGIS Online account enables you to pull in different base maps and data into your ArcGIS Pro session. So it's kind of worthwhile having an ArcGIS Online account anyway, if you're going to use Pro. I think it's almost borderline essential to do that. So once you are into ArcGIS Pro, you probably want to add some data because, you know, that's what it's all about, right? So there's a few different ways to go about it depending on what kind of data you have. If you have data stored locally, what you want to do is navigate to the Map tab, and in the Layer section, you'll see an icon for Add Data. And if you click that drop down, the very first choice is just plain old Add, and that's what you would want to use there. You'll see a window that will allow you to navigate to the folder that contains the data that you want to add. Just click on the files that you want and click OK. And then there are some other options when you click Add Data. So like I said, Add is the first option you'll see, but there's a bunch of others. We'll see a slide later that illustrates what those other choices are. I wanted to point out right now that one of the other options is retrieving data via a URL. So that's something you would do from this interface. Now, if you have data in ArcGIS Online or you want to use data that's stored in ArcGIS Online, there's a different way to go about that. Here you would want to go to the View tab and open the Catalog pane. Then once you're in the Catalog pane, you click the Portal tab at the top. And once you're there, you see choices like, I want to add something from my content or from groups or from anything in our ArcGIS Online portal or from Living Atlas of the World. So that's the way you would go about adding data from that source. And a base map is always nice to have, and there's lots of choices. However, the first time you're using Pro, if you do want to have choices for your base map, I've outlined the steps here, and it's not intuitive, and I fell into this trap the first time I did this. So, but anyway, you'd want to go to the Project tab. In the Project tab, you'd want to choose the Portals page. Then when the Portals page comes up, you want to hit the button that says Add Portal. You'll get the opportunity to type in this URL. Then you go back to your map. And then when you click on base map, you will have choices on what kind of base map you'll be seeing. And lastly, tools. We'll be using some tools today. And there's a bunch of different ways to get to things. There's a lot of redundancy, but in general, if you just want to try to find a tool and you're not sure how else to get there, you'd want to go to the Analysis tab and click on the toolbox. And once you do that, the geoprocessing pane will pop up on the right-hand side of your screen. And there are several like sub toolboxes. And if you know what your tool does, you can maybe figure out what sub toolbox it would be in. But I'm finding that oftentimes it's a lot more straightforward just to type in a word or a phrase, and it will come up with a list of choices that seem to pertain to what you want to do, and you can take it from there. Although sometimes that doesn't work super well. So it's kind of, I think it works more than half the time from my experience. But anyway, if it works, that's great. If not, then you have to maybe do a little more digging to find the kind of tool that you want to use. And before we go any further, I just wanted to mention that for this workshop, it's not really intended for you to be following along and trying these things as I'm talking. It's more like, watch what's happening here, wait till you get the slides. You can go over some of the stuff and kind of learn from it that way. And we'll also have an in-person event 1 week from today in Orbach Science Library here at UCR. So if any of you want to come to a lab that has computers set up and you wanted to try out some of this with me hovering around and trying to answer your questions, we can do that as well. And there'll be a slide at the end that talks a little bit more about that. Okay, so let's go ahead and talk about performing joins. And let's start with table joins. I think this, well, I don't know if it's more common than spatial joins, but it's certainly popular. Why do you want to use a table join? Well, it's when you've got attributes on a table or a spreadsheet, and you've got a spatial file, and you would love to have those attributes from the spreadsheet represented on your map. And this is a way you can just get those on there instead of copying one by one into cells on your attribute table for your data. So it's very nice to have this option. And a use case would be maybe you have some tabular election results by county, and you have a map of counties, and you would really love to show those election results on your map of counties. So a couple things about doing this. Both the data table that you have and your attribute table for your map, they both must have a column or a field, which is a field that contains the same spatial identifier. So census tract number in the table, you need to have census tract, a column in your spatial file, and so forth. City name or whatever it is, you know, that has to be the same type of spatial identifier. And it has to be expressed identically. So what that means is that you need to have consistent use of capitalization, or abbreviations is one that might really trip you up. Like if you have the states of the United States and your tabular data says AZ for Arizona, but your map spells it out as Arizona, you know, you're going to have to do some data cleaning to get that coincidence so that Arizona means Arizona in both of those, like they're absolutely a match. Something else you might have to watch out for is the data type, like whether it's expressed as an integer or a string value, and that kind of thing. And I've got a link in here that talks about if you do have a problem with a mismatch in the data type, it tells you how to change one of the data types so that they do match. If you have point data and it's latitude and longitude for representing the point, in the data table, there has to be one column for latitude and a separate column for longitude. Doesn't work if they're all smushed together into one column. So just be aware of that. So although I've been talking about how the data has to be, you know, a good match, identical almost, the column headings don't need to be identical. So at least there's a small grace. You don't have to worry about changing what the column heading says to do a table join. So what I'm going to do is show you a couple of slides that go through the process, and then I'm going to cut over to a session in ArcGIS Pro and hopefully demonstrate how this works. So to join a table to your data, you would want to bring in both the spatial file and your data file. But in the contents pane, you would want to right click on the layer that you want to add data to. What is the thing that you're trying to change? And that's what you want to right click on. And then from the choices that appear, you'd want to go to joins and relates. And from the choices that appear then, you would want to go to add join. And this is what the interface looks like. Again, on the right-hand side, you're going to see this geoprocessing pane pop up. And add join is one of those tools, but here's an easy way to get to it, right? Just right-clicking on your layer that you're interested in. And there's really only a few things you have to worry about. And we'll talk about how you go about populating all this. And what I'll do right now is escape out of my slides and go over to my Oporto session. So what I've got in this first example is I have a spatial file that shows the countries of the world. And I also found a CSV that has data from the happiness survey. I don't know if you've ever heard of that, but every so often there are these researchers that survey how happy people are in the different countries, and they rank the happiness scores. And I thought that would be an interesting thing to bring into my map. So what we can do is go up to the layer that I've got that represents the countries and right click on it. Oh, I do want to show you the attribute tables for both before we get going. So good thing that's also on a right click. So for this attribute table for my world countries, you can see I have a column that's called countries, and that's pretty convenient because that's what I'm interested in, right? But luckily enough, the first few rows in my table kind of show me islands that are not actually countries themselves, but they are affiliated with a country. So you know what? I happen to know that my happiness data, if I open that table, that has kind of your standard, what you think of as standard countries. It doesn't get into the little islands and everything. So I think I want something that's going to match what I have in this table if I have the choice. And sure enough, I do. There's this other column that's called country F, which I think means country affiliation. And I think that's going to work better for my spatial join, or my table join in this case. I misspoke there. So anyway, let me close these two tables. And now that we've seen the kind of things that they have in them, now I'm going to go ahead and right click again. And I'm going to go to joins and relates. And then I'm going to pick add join. And it's thinking. There we go. Okay, now since I right-clicked on the layer I wanted to add data to, it's already populated in my first window. So yay. If you made a mistake on that, you have the option to navigate to whichever layer that you do want to modify with the join. So the input join field, now this is why it was good for us to look at the table, the attribute table first, because here I get a drop down of all the column headings from that attribute table. And instead of going for country, I'm going to go for this country F. And then, you know, ArcGIS Pro is pretty smart. So it recognized that I do have a CSV in here, and that's the only table I have in my session right now. And so it went ahead and populated, what are you going to join to your layer? And it picked the right one because it's the only one there in this case. But if you had several CSVs, you'd have to, you know, make sure from the drop down that you picked the right one that you wanted. And it's also smart enough to recognize, oh, this table has a column that's called country, and I bet that's the one that you want to use as your join field. So that happens to be true, but sometimes it doesn't guess right. So you just want to make sure and not just blindly accept what's populated in there when you do that. And then you click run. And that didn't take too long. So it's always a good idea to check the outcome. And I will go over here and right click and open my attribute table again. Okay, and now remember before, all we had in the attribute table for my map, it stopped about there, but now I've got, again, the fields related to the happiness values. So now I have that associated with my map. So that's pretty cool. And we'll come back to this a little bit later in the workshop. But for now, I want to go back over to, not that. Oh, let me pull this down. There we are. And slideshow. Okay. So I wanted to say that if you see this warning when you're doing your join table, you might be a little concerned about that. I tend to get concerned about warnings. In this case, what this is saying is that that field wasn't indexed. And that just means like how many unique values are in that column altogether. And if it's indexed, that'll speed up the process of doing the join a lot more than if just running it as I did. Now, mine didn't take very long because I only have like 200 or so countries to deal with. But if you have tens of thousands of rows in your data set and lots of repeats, doing this index would be very helpful for the processing to go faster. And it's pretty easy, fortunately, to take care of that. There's a tool called Add Attribute Index, very simple interface. I did it for the first time and did not mess it up. So that's a good indicator that it's not that hard. And then once you run that tool, you go back and try your join again, and it will probably, if it was having problems in the first go round, it'll go more smoothly now that you've done that. And if you're interested in saving the result, what you can do is export the map. And this is not intuitive in my opinion, but here's how you do it in ArcGIS Pro. You would right click on the layer that you want to export. You go down and find data in the choices, and then you pick export features. And then isn't this interesting? Instead of a tool that says export feature, it's called feature class to feature class, which is, yeah, but you know, it's kind of a switch in terminology here, but it does what you need it to do. It'll save it as a shapefile or something like that. So anyway, that's what you would do if you wanted to preserve your results. Okay, now we'll talk about spatial joins. When would you want to use a spatial join? Well, it would be when you've got attributes in one layer of your map and you want to add those attributes from the one layer to a second layer, just based on their spatial relationship. So I've got some use cases down there at the bottom of the screen. Maybe you have a point file that each point represents a crime that occurred. And you've got a polygon layer that might be the neighborhoods in this big metropolis. And the crime data currently does not have an indicator of which neighborhood the crime occurred in. So people might be interested, well, can we add that to our data set for the crimes? And yes, you can with a spatial join. Kind of flipping that, you can also go the other way with it. And maybe you would want to know in this neighborhood, how many crimes or points were there all together. So you can do that kind of a spatial join as well. And then there's even a possibility to use proximity here. So in this example, like maybe you have a map of the recreation centers in this big metropolis, and you would like to let citizens know which mass transit line should they take, which one will get me to the closest to this recreation center. So spatial join can do proximity as well as just like right on it or right in it kind of thing. So a quick mention about projections. This may be a factor when you do a spatial join, and I'll just kind of go through the slide. ArcGIS Pro will use the coordinate system of the very first layer that you've added to your session, and then each layer that you bring in after that will be reprojected on the fly to match the projection of the first layer. Now that's fine if you're just looking and noodling around and all that kind of thing, but if you're getting really serious about, I need to do analysis, I need to make absolutely sure that my data is sitting right where it should be, I need to do some editing, so forth. Just relying on this on the fly reprojection is not recommended. Fortunately, there's a couple of tools that you can use to fix that once and for all, so it's not being done on the fly. They're called project, and that was what you would use if you just have one to change. If you've got many layers that you all need to reconcile to this very one coordinate system, then you would use batch project. And I've got a link to more information about how to go about doing this kind of thing. Anyway, just a brief aside, this is where projections might trip you up if you're not careful. So in my spatial join example, what I've done is find data for the city of San Diego or the San Diego area. And I had I found a data set that gives pothole fixing requests. So citizens were able to stand in a place and look at a pothole and click on their cell phones and go, hey, there's a pothole here, you guys need to fix it. So there's this big database. I just extracted the data for 1 month. That shows you how many potholes there are in San Diego. And then I have a layer that represents the council districts. And I thought that that might be an interesting thing to bring together. So we're going to start with bringing which council district does each pothole fall into. So I want to add what council district it is in the polygon information. I want to add it to my points layer, which is the potholes. So we'll start with that. And what you would do is you need to have both your polygon shapefile and your point shapefile in there. In this case, like I started with, it was a CSV of potholes. And the way you get that to represent as points is you go to that add data icon like we saw before, but instead of picking data like we did on the first one, XY point data is what you would do. And if we have time later on this workshop, I will show you how that works. But it's pretty straightforward to get that to work. So anyway, once I did this with my pothole data, it generated all these points on the map. And then what you would do is, again, you have to think, which is the layer I want to modify? And here I want to modify the pothole representations because I want to add the council district information to all of my points. So I'm going to right click on the thing I want to change, which is the potholes. I'm going to pick joins and relates, but this time instead of add join, I'm going to drop down here to spatial join. And you get a different interface called, oddly enough, spatial join. So let me exit out of here and go back over here and go here. Okay, so different colors, different day, different colors. So what I just said was I want to change this, and I want to go to joins and relates, and now I'm going to go to spatial join. And so here, this join features, you just pick which layer you want to interact with, and here is my district data. And it gives a default name for your output feature class. So this is the business end of this down here once you get it set up. A couple of nice things about this. So here's a list of the output fields, and it contains all of the fields from both of my data sets. So you can kind of tell this was the council district column headings. They're all caps. And all of these other things appear in the lowercase. That was my pothole data. And it's what's nice is that if you know that you do not want, say, where's it, the phone number of the council person on this map, you know you're never ever going to want that on this map, you can just click on this and you have an option to get rid of that. You also have this handle, which means you can drag any of these up and down and change the order. And you can even get rid of some of the columns in your original database, or your original layer, which is nice. So you can really customize how this resulting product is going to be. It's not going to have extra data that you don't really need if you want to do that. Yeah, so if I just leave everything the way it is and click run, okay, it says it's complete. And what I have down here, if I open the attribute table for this, I'm going to see I have all of my usual information about potholes, plus at the end, I now have like the council person's name and all that kind of thing associated with it. So let me go ahead and do the opposite thing now. Like I thought maybe the council people would like to know how many potholes do I have in my district versus this other guy over here who thinks he's all that, but I think he has more potholes than I do, or something, you know, something like that. So what we can do is do a summary of how many potholes there are in each of these polygons. So what I want to do this time is to change the district data layer. So I'm going to right click on that, go to joins and relates, and go to spatial join. So it's already populated with the field I want. It's just making sure that I've got the right layer. Output feature class. Now this is a little different. Again, you can modify or delete some of the fields that appear. But over here, instead of picking this first or letting the merge rule be first, what I want to do is pick from among these choices. And you see, this is interesting. Like for what I want right now, I want to pick count. But if you had some of these points that had some value associated with it, it would be interesting. You could do things like, what's the mean value of the points, and so forth and so on. So it gives you lots of choices that way for spatial join. So I want to have a count, and I can click run. It may be popping up like that because I've already done this earlier on. Yeah, so here it is. And if I open the attribute table here, I have, oh yeah, I have this field. Now, some of the polygons didn't have any potholes reported in them, so that's why these are a null. But coming down here, I start to get to some of the join counts here. So yeah, that was interesting. Anyway, you would get an accurate count of the number of potholes in each district. And let's go back over here. Okay, so this was going back to the first one where we added the polygon data to the points. This is a screenshot of what the results were like. And then this is what I just showed you with the spatial join, and you could pick count and it would populate correctly. So anyway, now I have some resources for you if you are interested in looking at more about joins. At the top, I've got a couple of basic or broader resources that talk about joins in general. Then I have a couple here that are regarding doing tabular joins, and then a couple here about doing spatial joins. So now we'll look at making a Choropleth map. So make a Choropleth map when you want to represent the relative amounts of something in defined areas. So it's important, and I'm going to say it again on the next slide too. You would want to use normalized data, not raw amounts. It's very important not to be deceptive when you're making a Choropleth map. So use cases would be, what would it be the percentage of the population that has a particular health condition in each county? Or how do states compare regarding per capita income? So again, those aren't like raw numbers. They are, calculated on a percentage or something like that. So here are some things to think about when you're making a Choropleth map to do it right. You don't want to use raw amounts, again, emphasizing that because it's important. You want to make sure that your data's field type is numerical and not string. And then choose wisely, and I've got some resources on a resource slide coming up that talk about this. What classification method you use, whether it's equal interval or quantile or, Jenks or natural breaks. There's all different types of ways you can break up the distribution of your data, and you want to choose one that really makes sense for the data that you have. The number of classes, I think what the recommendation is typically is between 3 and 7. If you get too many classes with colors, it's really tricky. The human eye starts to have problems distinguishing between this shade of green-gray and that shade of green-gray, So it gets, you need to find that balance between having enough information on the map, but not being confusing to the person who's trying to read it. And then the color ramp you pick is important too. There's lots of color gradations that you can choose from, but you don't want to be misleading. For instance, especially these days, I think if you were representing election results and you had Democratic and Republican results and you used red for the Democrats instead of the Republicans, that would get a lot of people confused, right? So you want to be mindful of what you think your audience will expect the colors to represent and kind of follow that. So it's really easy. What you do is just right-click on your layer, and one of the choices that comes up is properties, and then you can get to symbology that way. And that's where you get to pick graduated colors as your choice of symbology. So what I did was go back and use that happiness data and made a Choropleth map from that. What you would do is pick graduated colors again. You choose which column or which field in your data is the thing that you want to represent. And there's drop downs for picking the method. You can adjust the interval size, the number of classes. You can pick a different color scheme and all of that good stuff. So let me go back over to my session and we're here. So I've already got, this was, I'm gonna turn this one off, and this is the one I have that has the happiness data joined to it. So what I get to do is just right click and choose symbology. And now you see the table, the field over here is all about symbology. Rather than single symbol, which means it's all one color, I am going to pick that graduated colors option. Oop. And it just randomly picked one of the fields that I have. This is not the field that I want to represent, however. I would like to get the, I'm going to use a happiness rank. And what I determined is because it's a rank, I picked a defined interval for that because everything is just one step apart from each other. So with 155 countries, that turns out to be each interval has 31 in it, which is pretty nice, of 5 classes. And down here is the color scheme. The one I prefer to use for this, and it's a judgment call, but I thought going from darker to light made more sense, although maybe it doesn't. And this is something you can play around with and figure out. So now what I've got is that the 31 most happy countries are represented in this dark blue, and then the next increment, goes to this kind of blue-green and so forth and so on. So, and the countries that have the less happiness are the yellow, so kind of lighter color. There's less happiness, and you can see that some countries were not included in the survey. So that's an issue that you might encounter as well, and you'll have to figure out how you would want to represent that. But anyway, that's an example of a Choropleth map. So here are some resources, like I said, basic advice for Choropleth maps, how you'd use them in ArcGIS products, and color choices. Color Brew is really great if you're especially if you're focused on distinctions that people who have color blindness and maybe other issues, they might benefit from some color ramps over others. So this is a website that helps you pick and determine that. And yeah, here's another resource that talks about creating these kinds of maps. Okay, before I go too much further, I know we're getting close to time and sometimes people have to leave. So what I'm going to do right now is pause for a second and post in the chat the information about where you can find the recording. And there's also a link for a survey about this workshop. So if you have time at the end, we really appreciate your participation in just giving some feedback about this workshop. There's a choice of like 3 questions. You just pick one that you want to answer that's relevant to this workshop and your feelings about it and answer it. So it just takes a couple minutes, but it really does help us. So thank you for that. And let me take a drink of water real quick and just pause and see if anybody has any questions at this point. Okay. So hearing none, we'll go on to the last 2 things, and these are pretty brief. Generating centroids. So you generate centroids when you want to create a point feature that represents each polygon. And you might want to do this if you want to present the user with a different feature to click to view data. So what I'm thinking of is, for instance, maybe you have a polygon file that's got all the counties in the state, say, and it's got just lots and lots of data about all different types of categories like health, income, racial distribution, all kinds of things, right? But you might want to restrict or let the user click the point to get maybe data on obesity, but then have maybe the polygons shaded, like in a Choropleth map, that convey information about income, which is like a different category. So you can do that kind of thing by creating centroids and letting the user interact with them as well as the map itself. And it's really simple. To generate centroids, you go to the feature to point tool. Again, doesn't have the word centroid in it, does it? And it's a real simple interface. And the only thing that you really have to think about is whether to check this box that says inside. So if the box is not checked, which is the default, the point that's generated will be at the center of gravity for that polygon, which may not be inside the polygon. If you have some weird shapes, you know, I'll show you a couple of examples. You might actually have that point land outside the polygon, and that might not be what you want at all. So if you do check the box, the point is assured to be inside the polygon, although it might not look like it's centralized in the polygon. So here's an example I used with some parking lots. So with the inside unchecked, you see I have a little bit of a problem over here. If I really wanted that point to be inside this horseshoe-shaped parking lot, it's not there. When I checked the box, I now have the point sitting inside the polygon, although why it picked this location and maybe not this location, I'm not sure. But the cool thing is with these points, if you don't like where they landed, you have the ability to edit them. So you could, you know, click and drag this point over to where you would like it, and that's not going to break anything. It's fine. Notice like this one, this point is inside the polygon and this point's inside the polygon, but they ended up in different places. So it's kind of a mystery to me. I'm sure there's a mathematical explanation for why that happened. But anyway, that's the basic idea, just that real simple tool. And sometimes you will see symbols like this on a map. So these will be centered or inside polygons. And if they're graduated symbols based on the quantity of something, or proportional symbols. So these are not centroids in the sense that they are not separate from the polygon layer. They are just the way the visualization of the information in that polygon, but you can't like drag them around or anything like that. You can't click on them and get extra information. It's just the color or the size is what the information is conveyed. So I just wanted to mention that in case you do see maps that have these kind of symbols on them, they may not have been created by using the feature to point tool. They may just be part of the symbolization of the map. So I'm thinking maybe I have time to go back over to this again and show you. Yeah, I think I like it here. Let me show you. This is a good area of the world to look at centroids. So let me pull this. If I turn this on, yeah, you would get to see, and you know what I need to do is pull this up. There we go. So here's an example. It did have the box checked when I made the centroids here. And this one represents Vietnam, but it's actually showing up inside Laos, which already has a point of its own. Similarly, this centroid over here represents Malaysia, but Malaysia is this landmass and this landmass. It's not in the middle of the ocean here. So that's kind of the problem if you use the, if you don't check that box. But if I wanted to If I wanted to generate centroids, here what I would do is, yeah, I have to follow my own rules, huh? Go to Analysis and Tools and Feature to Point, something I've already pulled up. So my input features are going to be this world countries. And now if I click the inside box and run it, it's still running. There. So now you see I can turn this one off. And you see that Vietnam has its own point inside of it and so forth. And Malaysia now has a point inside the landmass. So that's how that works. Okay, and there's some resources. You can also get a little trickier with centroids, including like you would be able to enter the centroid coordinates into the polygons attribute table if that was important to you. There's also a way to have weighted centroids, such as if there's a population distribution, say within a country, it could generate to where you know, where the population is more, the point would be shifted over in that direction. So that's a way that this explains how you might be able to do that with your point data values. Okay, the last thing real quick is to make a heat map. Use it when you want to visualize dense point data. If you want to show the relative difference in importance of occurrences, and there's a use case down at the bottom that kind of talks about that. Or if you want to avoid accurate depiction of sensitive data. So for instance, I'm thinking of maybe petroglyph sites, right? Those are very important, and you might want to have a map that shows in general where they are, but you do not want to give people the absolute location of each petroglyph, because unfortunately that might open it up for people finding them and defacing them and things like that. So if you have a heat map kind of thing, it doesn't get real specific about where these things are, but you could tell that there's more of these in one area versus another. So the use cases for making a heat map is maybe which parts of a city have the highest number of traffic accidents, and each accident is represented by a point, but you can change that very easily to a heat map. Or, and this is where I'm talking about the importance of the occurrences. You might want to have a map that represents either where there's lots of crime or serious crimes, or maybe there's a district that has lots of crime, but it tends to be on the relatively minor side as things go. Then you might have another district that has fewer crimes committed, but they're all pretty serious. You know, that might be useful to show on the heat map as well. And again, you go to the symbology and you choose heat map from the top drop down is all you have to do. If you need to get more advanced, there are tools in the density tool set that allow you to analyze the density values and that kind of thing. So that's if you need to get more sophisticated than just making a representation on the map. So a heat map, this is where I was talking about, this is the interface. If you were adding a CSV table, the interface that you get would look something like this. And the thing is that you just have to help the tool recognize which field represents the X value and which field represents the Y value from your data set. And that's how you would go ahead and generate that point layer from a tabular data set. But anyway, if you haven't done that yet, then you would, once you do that, you would right click on the layer in the contents and choose symbology. In the symbology window, click the drop down under primary symbology and choose heat map. So this is kind of what that looks like once you get there. Then you have some things you can fiddle with to make the heat map look better or worse. It's really a matter of trial and error, I think, based on what you're interested in. So the radius changes how much of an influence each point has, and you'll see, you can play with that number and see what that does to your map. The weight field is something you can use if there's a value associated with your points that you want to emphasize, as well as the number of points in an area. So for instance, this map was generated from locations of Chipotles in the United States. And maybe it's interesting to know that this looks pretty dense for the Northeast on the number of Chipotles. But maybe if you're a manager for the corporation, you'd want to know, and how much money are they generating, you know, that kind of thing. So if there's a monetary value, that could be also represented in the heat map as well as the locations themselves. And again, you have a choice of color schemes. I like the default one. I think that works pretty well for most cases, but you could change the color scheme to something else. And if you wanted to change the transparency of the heat map, it's not done from this interface. I looked and looked and I thought that's where it was, but it wasn't. Really what you can do is go up to your main ribbon at the top. There's an appearance tab under the feature layer, and it's not labeled as transparency, but it's this thing. It's got a slider, so you can slide it to make it fainter and fainter, or you can type in a value and see what that does if you wanted to change the transparency. And the constant versus dynamic setting, this is a little confusing for me, and I've played with it a little bit. Constant means that the way the density is represented will be the same, will show up the same for your whole data set, like whether you're zoomed in or not. But the dynamic one will kind of readjust the symbolization based on how much you're zoomed in. So it won't keep the relative values the same from one part of the country to the other. It's going to be just contextual within an area. Yeah, when I play with it, I don't quite get it, but I'll take their word for it that that's what it's doing. So we have some resources here for heat maps. Some step-by-step instructions. This one is good if you're interested in creating those weighted values for your heat map. This talks about how to use that density tool set to really analyze the density. And then this is just another representation of somebody showing you how to make a heat map. So I can cut over to the this one more time. I know we're getting up close to the hour, so that's why I'm hesitating a little bit to go over here. But let me go to, we can use this data real quick. So if I wanted to say represent the density of these potholes, I can just go to Symbology. And instead of single symbol, I can pick heat map. And there you go. I mean, that's all there is to it. And like I said, you can play with what happens when I bring the radius down, all that kind of thing, color scheme, all that good stuff. So it's really, really simple. Okay, let me go back and tell you that this is about the in-person practice session. Thursday, February 10th, a week from today, from 2 to 3, same time. I'll be in Orbach Science Library, room 122. It's the classroom. As you enter, you would want to go to your left, and you'll kind of see it along the left-hand wall there. And just a chance to try out your skills and ask me any other questions you might have about stuff you've got going on. I would try to answer them as best I can. And that is it. Thank you so much. And we have a few minutes for questions if you have any. Okay, you're welcome. I hope that was okay. I know I was expecting a little bit of understanding about the tool and everything, and it might be pretty complicated if you're not super familiar with, or have basic familiarity with ArcGIS Pro, but hopefully that helped. Okay, so there's a question about raw data. So that would be say, well, again, I'm going back to election results because I think of that as a kind of recent example. If you have the map of the United States and it's just like the raw numbers of people or votes, and you're just using that number to represent value in each state. That's a little bit misleading because some big states have very few people and vice versa. So what you'd want to do is like, percentage of the voting population that voted this way rather than just the raw data. So I hope that makes sense. It's just kind of normalizing it and giving it some perspective, which makes it a little more fair. So. And some of those resources I have at the end of that Choropleth session, they will go into more detail about the importance of normalizing your data. Okay. All right. Well, thank you again. My contact information is on that last slide. Feel free to reach out to me with any questions you have about this or other geospatial topics, and I'll do my best to help you out. So, thanks.